Hello guys, welcome to Exercise Physiology screencast, first one for phys. Okay, so basically normal format, pause wherever you feel relevant. Some of them will have memory methods, others won't. I suggest trying to use the transition slide just to try and, if you're struggling, don't go straight to the answer before you've given your brain a chance to actually work around the problem. Okay, so starting off then, explain how the aerobic system provides energy for sports performance. Okay, so what we're looking for is a kind of, if this is a 6 mark question, you do not need to write in full-on continuous prose. Okay, you can abbreviate, you can use arrows, you can use diagrams. So basically what I'm going to do is try and give you just a little link. Okay, so basically if you've got ag, ket, okay, you've got ag, k, and then you've got an ET at the end. They are supposed to stand for the 3 stages within the aerobic system. Okay, just to give you a little thing. So AG, K, and then you've got ET, you'd have C on the end as well. Okay, so basically go from there. The aerobic system is fuel, so you've got glycogen and fats. Then aerobic glycolysis, what we're looking for, takes place in muscle cytoplasm. Glycogen, GPP, glucose, PFK, pyruvic acid, as well as 2 ATP released. Pyruvic acid then joins with coenzyme A, okay, because oxygen is present, okay, and then forms acetyl-CoA. So basically what you've got there then, once you've got that coenzyme A, you've got that kind of point there. At that point, it enters a Krebs cycle. Matrix of the mitochondria, and then acetyl-CoA plus oxaloacetic acid forms citric acid into the Krebs cycle. In the Krebs cycle, CO2 is produced and expired. Regeneration, because there's oxygen present. Regeneration of oxaloacetic acid, 2 ATPs and hydrogen. So 2 ATP is going to give us our energy, and then we go to hydrogen. Hydrogen is the key now. So hydrogen basically then enters the electron transfer chain, which takes place in the cristae of the mitochondria, and then you've got the next concept. Hydrogen then, the electron within hydrogen will join NAD and FAD as they are electron carriers. What happens then is they will enter the electron transfer chain. Hydrogen is split, okay, so within that electron you have an ion and the electron, okay, so what you have there, due to oxygen being present, the electron will join and bind with hydrogen to form H2O, water, which can be sweated out, etc. And then the concept of the other split forms a massive kind of surge of energy, which is going to give you 34 ATP. Okay, so basically the whole concept behind it, total energy production ATP, 38 ATP. Okay, and then you're looking at kind of, all right, how's it used? We'll give an example. The question asks for an example. You can see if you think aerobic system, oh Jesus, that's a lot to write, but really, you know, if you shorten it, it's not that much to write at all, and it's definitely worthy of a 6 mark question. Used for low, moderate intensity and a high duration activity. So you're looking at things like marathon running. Now, this question comes as your only standalone energy system that hasn't come up on its own, so it's really important you understand the kind of breakdowns. You can put this into a visual if you want to get this revised as a diagram. Next question. Define the energy continuum. So you get 2 marks for that. Use an example from an invasion game. Explain how the energy continuum works. So basically from there then, you're looking for your key thing. I'll put your key trigger word, relative. Okay, so when you're looking at energy continuum, I mean, you know, I've changed this from the pack. So basically, you must make sure you start with this key point. So the energy continuum then is the relative contribution of the 3 energy systems, and the key variable is intensity and duration of activity. Now, another mark you could get for a description, energy systems do not work in isolation. They interact with each other. The interaction depends upon the thresholds of which they are activated. So the thresholds reached in terms of intensity and duration, one will switch off, another will switch on, and they interact constantly like that. So basically, for example, when playing football, how do we do it? We have to talk about each energy system. We have to give an example of an activity within it and then say why the energy continuum would suggest that that is the energy system that is being used or predominant. So what we're looking for then. So ATPPC system, you would have an example for a tackle or a long pass or a shot, something that's explosive because it is high intensity, low duration. when making a forward run and then a recovery run, or hitting multiple rucks, okay, or breakdowns in rugby, okay, you basically, that would use a lactic acid system. So any recovery type sprints or multiple recovery sprints where you're having to move to a number of times, that will be the lactic acid system because it's high intensity and a low to moderate duration. Finally, when you're jogging and walking throughout a 90-minute game, you'll be using the aerobic system because it's low intensity and high duration, and it allows you to respire aerobically and breathe oxygen in whilst walking or jogging. Okay, so that's how you put it into an example. This caused problems in the mock. People were writing loads of stuff they didn't need to. So you just need to make sure you talk about how the energy systems differ during the same game. Okay, and the different actions that would be used. Moving on then. Explain the alactacid recovery system. The key component here you're looking for, it's probably a 5-mark question. When you look at it and it comes up, we're looking for a letter there. So the key letter we're looking for is the A. So I always think if you look at that A and you think, right, this question is talking about the absence of lactic acid. So we're not talking about the lactic acid. That is not in your answer. Lactic acid does not get mentioned at all. You do not mention that the A is to do with the absence of lactic acid. It's just something in your brain that it's there for a reason. It'd be called the lactacid if it's talking about the lactic acid being removed. So it's not talking about lactic acid. From there then, these are your triggers. You're basically saying what, how, oh. Now I think that is the way you should be looking to doing it. So basically you've got 2 whats, 2 hows, and 2 O's. The 2 O's are to do with oxygen, okay? And then, I mean, you could have a third O as well if you wanted to. So basically, what does that stand for? So firstly, I mean, obviously, EPOC needs to be in your answer. So excess post-exercise oxygen consumption. That is what happens at the end. That's what returns your kind of heart rate to its resting state. Now, what we need to know then, first of all, is what is the alactacid system? Okay, then what does it do? What's the key focus of this EPOC? Okay, then how does it do it? Okay, so how does it actually take place? What type of reactions? How long does it take? And then what does oxygen bind to in order to allow this to happen? And finally, how much oxygen is required? And if you can kind of answer it and go, what, how, oh, oxygen bind with, oxygen, how much? Okay, and then we might be able to get somewhere near answering this. Now also you could talk about ratios. So answer will actually come to, what is it? Well, first of all, it's the first component and the fast component of recovery. It's the initial recovery. So if we're recovering, and I always think this is the best way to think about it, if it's the first and fast component, the first thing that's recovered is the first things that we kind of run out of. Okay, so the first thing we run out of is PC. So basically what we're saying then is, what does it do? Using EPOC, it restores muscle ATP and PC stores depleted during exercise. Now, the how does it do it? It does it via endothermic reactions, so using energy to bind smaller molecules into larger molecules with energy. Then you've got how long does it take? It takes 2 to 3 minutes. And then from there you've got the O's. Okay, so basically we're saying oxygen. It uses oxygen to break down fats and glycogen. How much oxygen is needed? 4 litres, or you could go 3 to 5. 3 to 5 is quite a good way to look at it, because then you know for the second system you just got to go 5 to 8. And you could also have something about our oxygen binding to myoglobin in the muscle cells in order to help recovery take place. Recovery ratios, so your 30 seconds equals 50% of PCs being restored and resynthesized. Okay, so have a look through that. What, how, oh. Okay, or we could have a triple O if you wanted to. Recovery ratios on top. Okay, so going on from there, next thing, define 2 types of flexibility and describe 1 way of measuring flexibility. So looking at that, you're thinking, right, do you know the 2 types? Secondly, can you describe 1 way of measuring it? So if I said to you quickly now, whenever you're talking about a flexibility, you need to think of the following way of remembering it. Okay, so ROM, SOM, and I'll put in here GOM as well, because that would give you a way. So ROM, SOM, so we always know any flexibility is to do with ROM, and then there's 2 types of flexibility. One is to do that takes into account the SOM, and the other doesn't take into account the SOM. Hopefully that makes sense. And then when we're talking about GOM, we're talking about a way of measuring it. So that would be 1 way you could do this. This is the main flexibility thing that hasn't come up, which is measuring flexibility. So what am I talking about? What does ROM-SOM mean? Dynamic flexibility then, range of movement. Okay, that takes into account speed of movement. ROM-SOM. Okay, then you've got static flexibility, range of movement, ROM, but it doesn't take into account SOM. And then from there, you're going on to your GOM, which is goniometry. So you've got a double-armed goniometer, okay, which basically looks at a neutral position, okay, and then measures a kind of an angle during flexion. So, for example, flexion of the hip, and basically looks at the difference between that to work out the angle differential to give you your flexibility reading. Now, the advantage is it can measure any joint on the body, okay, and up at the disadvantages, obviously it needs specialist equipment. Now I have put on here the sit and reach, which you might find easier to talk about, but remember, you've got to have very specific points you're going to use. So basically you're looking at, to start with them, adequate warm-up, okay, for a sit and reach. You need to also have place your feet against the box, reach forward over the ruler. Then you're going through, and I can let you read that bit from there, so you can go have a look at the advantage. Easy to set up, everyone's kind of used to sit and reach. You need a wall to make sure you have a rigid surface, but of course there's a lack of validity due to the fact that it only measures two areas, so your lower back, okay, and your hamstrings, and it's not really measuring. It's not great for a goalkeeper who might want to measure flexibility. Moving on then, an obese 18-year-old male weighs 220 pounds and consumes 3,500 calories a day. So basically, he currently takes part in no physical activity. Your job is to define basal metabolic rate and provide a value for the aforementioned male. Now, what I need you to do is explain how knowledge of energy expenditure and energy intake could help prevent obesity. So you get 2 marks for defining basal metabolic rate, and then see if you can work out a value, which requires you to know the equation for it, and then explain, okay, this guy is obviously eating a certain amount of calories. You'll be able to work out his basal metabolic rate. Once you've done that, you can work out something about his balance, his energy balance, and then you can maybe suggest how that balance could be altered in order to prevent obesity. So, firstly, key thing, defining it. Lowest is the key trigger I'm going to give you. So for basal metabolic rate, this is your equation. So weight in pounds times 10 plus body weight times 2. Okay, so that is your kind of equation that you should be going into the exam with. So I'll put it down here, 220 times 10 plus 220 times 2. So basically then, this is what your answer should come to. Basal metabolic rate, the lowest rate of energy expenditure needed to sustain body's essential physiological functions. Your figure should come to 2,640 calories, okay, in terms of his basal metabolic rate. So that's what he's burning at rest. Then he currently has an energy intake that exceeds his energy expenditure, okay, which causes a positive energy balance, which will lead to obesity. Now, your knowledge of energy expenditure, e.g. the use of metabolic equivalent tasks, e.g. you could say football, rugby, which is used as 7 METs, okay, for 60 minutes a day, this could help then lead to energy expenditure exceeding energy intake, which will create a negative energy balance, which is what is required to avoid obesity. Okay, moving on, last question then. Explain human growth hormone. Okay, give one advantage and one disadvantage of its use. So when you're talking about this, you're thinking, where is it produced? Is it natural? Is it synthetic? Okay, then you're talking about detectability. Okay, then you're talking about what's the good things about it and what the bad things about it are. Who is it good for? Okay, so basically going through, you've got your key bits in here. It's produced naturally in the body. It can also be produced synthetically. It's not detectable after 24 hours. So it's a hugely popular drug for both athletes, and I've talked to you about the kind of in terms of cosmetic world. Now, going on from there, what are the advantages? Glucose in the blood can increases lipase, which is a key enzyme in the breakdown of free fatty acids, and then it will stimulation of protein synthesis, so this can help via amino acids, so it can help healing of musculoskeletal injury. So basically you wonder how some of the athletes come back so quick. I'm sure this is one of the reasons. Big problems: diabetes, hypertension, and you get abnormal growth of organs like the heart, but you can also have the abnormal or the accelerated growth of kind of tumours. So if you have a cancerous tumour, taking human growth hormone will accelerate that growth due to the fact everything in your body is growing. Okay, it can be used for both aerobic and anaerobic performers.